And when I started on V8, I had probably written like 20 lines of JavaScript in my life before. So you can imagine that I was well prepared to work on a JavaScript engine. But I did some other stuff that might be related to my work. So first of all, don't panic. This is going to be very technical, but you don't need to get every detail. So I just want to get you some understanding of the interesting complexity that sits underneath new language features and in general JavaScript VMs. I will publish the slides later, and you can have a look if you want to know more. You can also ask me, so I can also respond to questions. So let's play a bit of buzzword bingo first. What do we want to do, or what do we want to accomplish with the V8 engine, or in general with JavaScript engines? We want to empower you to write modern, idiomatic JavaScript that can be run everywhere. So these buzzwords, modern, use the latest features because that's what makes JavaScript great today. Don't write ES5 code maybe because that's kind of ugly, unless you like it. Also write idiomatic JavaScript, so don't program to implementation details of the browser, but instead write code that you can understand in a couple of years because otherwise it will just haunt you. And trust me, I know what I mean. And JavaScript is pretty universal today, so it doesn't matter where or on what kind of application you're working on. JavaScript can be used for almost everything. So be it machine learning, be it your HTTP server, I guess even some parts of the ISS are running on JavaScript. At least I heard rumors. So it's just everywhere. And we want to empower you to be able to use it everywhere. Today I'm going to focus on this aspect of modern JavaScript, and I'm going to tell you what I mean by that. But first, let's have a quick look at the history of JavaScript. So it all started in 1996 when someone coined the term JavaScript after it had two other names before. And the first serious version was 1997 when the ECMAScript standard was formed and it started to get a bit more serious, not just a toy language. But it lasted until 2000, actually, until 2000, until it was really considered usable when ES3 came out. And then a lot of time passed by, and I think many people on the planet just hoped that JavaScript would disappear because it was so terrible to use, and it was just a toy language. And then something magical happened. Then ES5 was eventually published, so we skipped the 4 because of reasons. And that was when people started looking at JavaScript like, oh yeah, maybe we can do some applications with that even. And then the glorious days started, so then we got ES6, which we later renamed to ES2015. We switched to a yearly cycle, so we got ES2016, ES2017, and we're about to publish ES2018 in a bit. There's a different way to look at this. So there's the scale. Essentially, until like after ES5, everyone just hated JavaScript except for a few people, but the majority of people just said, nah, don't want to write JavaScript. And then there was a period where it was like, yeah, okay, maybe. And now everyone wants to write JavaScript. And a wise man once said, so this is Brendan Eich, which was the creator of JavaScript, or still the creator of JavaScript. And he said, one day, always bet on JavaScript. He even said that before JavaScript became so popular. And he was right. So back then it was always like, yeah, you cannot use JavaScript for that, you cannot use it for that, you cannot use it for that. And in the end, we could use it for everything. So we can just put any application, write it in JavaScript if we want to. So he was kind of a visionary in that way. So what's inside of JavaScript today? So the latest standard from last year contains a lot of awesome features in addition to the ones that were already in ES5. So we got classes, we got proxies, we got promises, we got async functions, we have arrow functions, and so on and so on and so on. So lots of features. So from a pure programming language perspective, JavaScript is a pretty decent language nowadays. How did we get there? It all started essentially with ES5. That standard was 258 pages, so you could probably write an ES5 VM in a couple of days, couple of weeks, I don't know, depends. But it was kind of decent. So then eventually ES6 happened, and it was also kind of a bump already. So all of a sudden the standard is twice as big as before, so the language grew immensely. And then The latest standard that we have nowadays is ES201X, and that's already over 800 pages, almost 900 pages. So that's a factor of 3.4 increase. So we have a hard time keeping up with that. So not just implementing all the features, but also making sure they work reasonably well in DevTools, they give you reasonable performance, and all of these things that we need to worry about in the end. And we don't even know how big ES20118 is going to be, because we haven't done the PDF version of that yet. There are some details. But it's probably going to be about more than 1,000 pages. And in ES20118, you got these amazing new features. Among them, there are async generators and async iterators, which are probably going to change the landscape quite significantly. So the way we write asynchronous code in the future is going to be very different from the way that it was written like two years back. Also, we have object rest and object spread, which is pretty neat, and a lot of very useful regex features made it into the standard. And the best thing about it, you can use all of that already in Chrome. So Chrome 64 and Node 10 support all of these new features already. So if you check the table, the so-called Kengax table, which you cannot really see well on the slides, but there's these columns for Chrome. You see that everything is green besides shared array buffers, which had to be unshipped for security reasons when the Spectre thing happened. But besides that, all the features are already available, and the other browsers also catching up. And Node 8, you can see the Node 8 column. Node 8 also almost supports everything except for the latest ES20118 features, but Node 10 supports all of them. And in Node, we didn't need to unship shared array buffers. So I also want to give you a brief overview of how new language features are being introduced to the language. So nowadays we have the TC39 committee, which is responsible for evolving the language specification. This is a committee of language experts, but also browser vendors and people from the Node community and from other JavaScript users. And if you're interested, you could even get involved yourself. So most of the stuff happens on GitHub nowadays to encourage involvement. And the process, there's a formal process for a new feature. Every feature starts at what we call stage 0, which is a straw man. And that's just, okay, I have this crazy idea. How about we just add some new feature to the language? You don't need to bring anything, just maybe a rough idea. Then it's already stage 0. So the next stage is stage 1, and at that point it turns into a proposal, and you have to bring some demo or a polyfill that at least describes or lays out the idea of how the feature is going to work. There's still no formal requirement for spec text, just some JavaScript and maybe some user feedback and all of this. This is stage 1. So stage 2 is a bit more serious. That's when you need to start a draft. So you need to formulate it in terms of the spec language. The spec has its own language. And you need to consider APIs, and at least the rough semantics should be clear. And they should make sense in the world of existing JavaScript. Stage 3 is when it gets serious. There's every feature that reaches stage 3 is considered a candidate for the language, and that's when we are essentially waiting, or that's when we get into the equation and start implementing this in the browsers. And once there are 2 compatible implementations, which currently means there are 2 browsers that ship it, it's stage 4 and considered this is part of the language now. Okay, so how does this look like in V8 land? We usually get involved, or at least my teams are involved when it's stage 2, because then we are considering implementation and maybe thinking about how this fits into the rest of the VM. From that, we go on to send an intent to implement, so that everyone knows, okay, we are going to implement this, update Chrome status, and come up with a design, how this works, and some initial prototypes. Usually we derive it from things that are, before it reaches stage 2, nowadays it's usually already in Babel or Webpack or some of these tools. So we already can take some ideas from that and turn that into a prototype. From that, we create what we call a baseline implementation, which is just first working implementation that we think, okay, we can ship this. And this baseline implementation is then staged, which means there is a flag that you can pass to Chrome to enable it. And eventually, after this had some coverage, we ship it, and then you can use it without a flag in the browser. And that's when it gets interesting, because the baseline implementation is usually just get it working. But to have a new feature, which is then terribly slow, this is not going to be amazing and not going to be used a lot. Also, if a new feature doesn't integrate into dev tools, this is also not going to be used very well. So you will just have the developer experience will suck. So then we start thinking, or we start seriously thinking about, okay, how can we make this fast? How can we make the developer experience great? And for this thing, we actually rely a lot on developer feedback. Because JavaScript is so complex, we can make everything fast if we want, with some exceptions. But if we invest in one fast path, and that is not the likely case, that's not what you're going to use, then we're wasting everyone's time and we're just making the VM complex for no reason. So here, if you want to get involved, this is where you could get involved in V8. And I want to show you one of the latest features that we shipped in Chrome, which is BigInt. You might remember this slide that I had yesterday. Anyone figured out why this is happening? No? Okay. Then I'm going to ruin my joke and explain to you what's happening here. So the thing is, in JavaScript, for whatever reason, Brandon decided that we base numbers in JavaScript on float64. This is a special binary representation for floating point numbers. And in float64, you have these 64 bits that are distributed like this. So you have an explicit sign bit, which says it's negative or positive. You have an exponent, and you have the so-called mantissa, or fraction. And then you have this complicated formula, which turns this into the actual number. I could give a whole talk just about float64, so I'm not going to bore you with this. But what it essentially means is that you have a limited range of integer numbers that you can present precisely. Actually, it's because of the fraction, because that's what you multiply. So you have up to 53 bits for precise representation of integers. 52 of those bits are explicitly stored. The last bit is implicit. And the range of these integers goes up to what JavaScript calls the max safe integer. Actually, it's the max safe integer plus 1, because for whatever reason, the spec defines max safe integer as the largest integer where you can still add plus 1 without hitting holes. So after that, you cannot safely add 1 because there are holes in the range of possibly representable values. What that means is if you take this number and you add plus 1, that still works. So you go from 991 to 992. Okay, perfect. Now if you start adding 2 to this, then you also get 992, because 993 is not representable via float64 representation. Now if you add plus 3, then you see, okay, now it works again, because this number is again representable. And now the cool part, you can use BigInts now. With BigInts, no problem. You can represent any big integer that you want, it works. Okay, there's a limit because of memory, but in general, the limit is pretty high. So you no longer run into these problems. So if you write scientific applications or anything that deals with money, especially with a lot of money, don't use numbers. So use big integers. Another example like this, so these are not even very big numbers, but if you start multiplying them, then you see there's something fishy. Just look at the last digit. The 0, that doesn't make a lot of sense if you multiply 3 by 9. That can't be 0. And in fact, it's wrong. The real number is actually this fancy number. So 3, 3, 3, 4, 4, 4, 4, 4, and so on. And in the end, you see a 7, which makes a lot more sense. Okay, and you can also go nuts. So just this really big number is still precise number. So that's an awesome feature. And the best thing about it, it's already shipping since Chrome 67, which we are going to release next week, I think, or it is already released. It's going to be out very soon. And all of this is going to be in Node 10, LTS. So you can start using it. Other browsers are also almost shipping it, or at least are close to shipping something. And the exciting part here is, although it's just a baseline implementation, just using, so we hadn't spent any effort optimizing for specific cases. But just the basic implementation of our backend already beats all the existing big num user space libraries, and one of them, so BNJS, the green one, was heavily optimized, and we are still way faster on average than that. There are probably cases when you have a narrow case, then maybe BNJS is faster, but in general, the native implementation is already very good. So that was a success story. But it would be boring if I stand on stage and just tell you about success stories. So we also have some accidents along the way of evolving JavaScript, but also catching up with the VM, and specifically on the performance side. So sometimes you wake up to these weird GitHub pull requests where you're dragged into, and then there's a lot of text, but when you get through this, you see, oh, something went from 2 minutes to 14 minutes in Webpack 4. And someone on the Webpack side complained about this, that this is a V8 issue. Okay. So that was probably me. Oh, not the one complaining, but the one who broke it. Okay, so what happened here? Let's go through this quickly. So there was a large Angular 5 project which had a shitload of modules, really a shitload of modules. And all of a sudden, when they upgraded to Webpack 4, there was this one plugin that just concatenates all the things, as we just learned in the previous talk. And that was taking 60% of the build time. And that 60% was not a couple of seconds, but since this was such a huge project, it was 14 minutes. So they already started digging into this, and they found out that this is just time consumed in 2 simple for-off loops. I'm going to show you that. And if they hand optimize it back to 4 loops, they could get it down to 2 minutes again. So that means your Angular developers, this is the difference between them going for a coffee while they're working or just working on their project. You can imagine it's annoying to wait for 14 minutes for your project to build or to bundle. So why did that happen, actually? They started using idiomatic JavaScript, modern idiomatic JavaScript in Webpack 4, which is great, so we encourage that. But something in here was not quite right. So this is the idiomatic version, pretty decent, right? So you have 2 nested for-off loops. Even if you don't understand how Webpack works, this code doesn't look complicated. And that was the hand-optimized code against which they benchmarked, and that looks not so nice anymore. And what went wrong here? So in Node 8, which was the Node version that they were running on, we had a fast path for array iteration in for-off, which is pretty common. Except that this fast path, for whatever reason, didn't hit here, because this new dependencies, the new module.dependencies had different array shapes, internal shapes to the VM, and then the VM was like, I don't know what you're doing, let's go slow mode. And that's then 14 minutes instead of 2 minutes. So if you want to know more about these things, there's a long blog post explaining how arrays work in V8. You should probably grab a couple of coffees when you start reading this, but it's very interesting. So what did we do? Well, actually, we fixed the problem. We widened the fast path. Once we knew what the problem was, it was fairly straightforward fast. We just had to come up with a new idea, and then we had a fast path that even is resilient to things like this and could work. And this fast path is in Node 10, and Webpack had this workaround, or still has this workaround, until they switched to Node 10, and everyone was happy. So what can you do in this case? First of all, it does make a lot of sense to measure your application performance constantly, because if you don't know that something is slow, that's not good if you only find it out on the customer side. Then if you find an issue, report the issue. So if you know the issue is in V8, which is not easy to tell, but you can at least report it to Webpack, so that's what they did. And then they can involve the right people or report it to Node. Do something, not just sit there and complain. Because if you report issues, we get a chance to fix them, or Webpack gets a chance to fix them. And remember that we are all humans, and yeah, we all make mistakes, and we are sometimes wrong, so just don't go bashing on the internet. That's not cute. Okay, and remember this picture from the beginning. So you're a part of this. You You don't need to sit there and say, I cannot do anything. You can. And even if it's just reporting an issue. Okay, another story. That was one thing I started working on end of last year. We get all these cool features, promises, async functions, async generators. And I want to show you one example of where we didn't go that well. This is very complicated, so I always need to draw pictures. I have a lot of pictures on the slides. Don't worry if you don't understand it immediately. You can look at it later again. But let's try. So we take this simplistic example. Unfortunately, this is almost the simplest thing you can build to illustrate the problem. So there are essentially two processes running. So the log function is just a helper. So you have a count2 process that just asynchronously counts from 0 to k. And you have a tick process, essentially, that just schedules itself via promise resolve and counts down from 10 to 0. Okay, and you start both of these processes. So you can conceptually think of this as two concurrent operations running. And the log function is async, just to illustrate the problem with await later. And this is, you don't need to have an async function here. The async just does the same as this, and it just gives you a resolved promise back that has the value undefined. So we stick to that example. So running this in Node 8 or in an older version of Chrome gives you this picture. So you see the processes are interleaved. So you get a tick, then you log, then you tick, then you log, then you tick, then you log, and so on. And the log gives up earlier, or the count2 is done when it reaches 3, and the tick just goes on. Taking the same code and running this in Firefox gave us this picture. So we were like, oh, wait, Firefox is wrong. Turned out it wasn't Firefox that was wrong, it was us. But this is pretty meh. This was hard. Okay, so we had to dig into this and find out what was the problem here. So why do we see a different picture? And yeah, I'm going to illustrate the processes themselves so that you get an understanding of that individually. So let's start with a tick. Tick starts with the value of 10, and then it always schedules itself as the resolution callback on a immediately resolved promise. So it all starts with the invocation of tick 10. That creates a promise that is already fulfilled with 9 because we pass v minus 1. And to that, we attach tick as a handler, which schedules a promise reaction job that invokes tick when it's run. So there's nothing else scheduled, so we run the promise reaction job. So we invoke tick 9. That creates a promise that is fulfilled with the value 8. That schedules another reaction job to invoke tick. That invokes tick 8, creates a promise, and so on. Okay, so this process is kind of simple to understand, kind of. So what's the deal with with await? If you stare at this page for a while, then you get a terrible headache. Trust me, I did this, I don't know how often. So this is the spec text for await, and yeah. Okay, let's not look there. It's just blah. Okay, let's understand this by the example. So we have the function count2, that's an async function with a loop inside, and inside of the loop there is an await, and that await awaits on a fulfilled promise. So the only interesting bits for us are the await and the resolved promise. So let's simplify the example to just this one line. Okay, so what does it do? If we invoke it, the first thing it does, it creates this promise v. This is not what await does, but what promise resolve undefined does. The promise is fulfilled with the value undefined. Okay, so then await kicks in. And the first thing that await does, because there's this abstract concept of a thenable, which is everything that has a then method on it that accepts 2 callbacks. So you cannot only pass promises into await, but any thenable is fine. So the first thing it does, it schedules what the spec calls a promise resolve thenable job, a really terrible name. And this creates a new, and hooks this up to a new promise, which is the actual promise of the await. So it waits, await creates P, V comes from promise resolve. Okay. Then await creates yet another promise T, because it's called a throwaway promise. I'm going to illustrate why it's called the throwaway promise. And it chains a reaction onto P, so that when P is resolved, we resume the count2 function. So the async function is being suspended at the point of the await, and only resumed later when P resolves. Okay. So then we are done with that, and we go on. So we execute the promise resolve thenable job, which then schedules a promise reaction job that fulfills the promise P, or that resolves the promise P with the value from the promise V. That's already tricky. Okay, so far so good. Okay, then we go on, and we execute this promise reaction job, which propagates the value from V to P. So P is also resolved with undefined now, or fulfilled with undefined. And it schedules another promise reaction job that, when executed, resumes count2 and also resolves the throwaway promise. And when that executes, we resume count2, and the throwaway promise is also fulfilled, but since there's nothing chained on that, we are done. That's why it's called the throwaway promise. And that's basically how await works. So takeaways from this, you don't need to remember this, there won't be a test or anything. But takeaways from this, await is probably a lot more challenging than one might think in the beginning. And if your application depends on things happening in a certain order, then you will appreciate that the spec is super precise about order. And most of the implementations are correct, so now we are also correct by now. Anyways, we are still working on a way to make it faster, so despite the overhead, you see that every await comes at the cost of at least 2 additional promises and 3 ticks to the microtask queue. But we are thinking about ways how we can hide this additional overhead so that it's still, you should use await, don't start promise chaining just because you saw the slide. So still stick to await, and we will make it fast eventually. Just go through the example quickly so that it sticks. Okay, so we have this, we take the Firefox example because that was right, and we start executing count2, and the first thing it does, so I take out the tick because that's not interesting. The first thing it does console log 0, then the promise resolve thenable job, then the promise reaction job for the P, then the promise reaction job for the throwaway promise, and then we are done again. So this is why we see 3 ticks in between. Okay, so what happened in V8? What happened in Node 8 actually? So the thing was, we had an optimization in there where V8 was like, yeah, okay, if I see a fulfilled promise, what's the point of doing the resolve thenable job, because it will just propagate anyways. And so the optimization went like this, where we were like, okay, it's already fulfilled, so just create the final promise reaction job. And so we only had 1 tick to the microtask queue. But the problem is this is observable. And if your application depends on this, you will have a hard time debugging this. You will probably scream and just give up on this. I would do this. So we had to remove it, and when you see such a commit in V8, there are already a couple of dangerous words in there: fast path, bypassing, benchmark. Something was not so good. Okay, so it's gone, it's fixed, and we'll probably backmerge it to Node 8. So I just learned this when I was preparing the talk last week, so I hadn't had time to do this, but we will also fix it in Node 8. Okay, so takeaway from this section. Scheduling is well defined of all these things, and this is a good thing because then it's predictable. So just otherwise switching between Node 8, Node 10, or switching between Firefox and an older version of Chrome, and all of a sudden you get different order and your application misbehaves. It's not good, you don't want that. The optimization potential on the one hand side is pretty limited because the spec has pretty clear steps that we need to follow. But actually, a challenging problem is also an interesting problem. An easy problem is not really an interesting problem. So for us, it's a challenge, and for you, it's a cool feature. And as you saw, it's also very easy to get it wrong. So we had 0 test coverage for this, of course. So if you don't test your stuff, then it might break. And you might even ship the wrong thing to millions of users or billions of users. But nonetheless, we made some significant improvements already on this. And this is what we got from basically V8 5.5, which is the was the version in Node 7. So that's the light blue line, to what we have in Node in V8 6.7, which is now in Node 10, which is the dark blue. And you can see that there are like almost 10x improvements on these promise benchmarks and async await benchmarks. So we do our best to not only provide you with the features, but also make sure that it has decent performance and that you can rely on it. So conclusion from that talk, I hope you're still here mentally, somewhat. JavaScript is a pretty great language nowadays. It has all these cool features that all the cool programming languages had before, and the JavaScript developers were like, I cannot use async await. Nowadays it has it, so you can use it, and you should. And make sure to not express implementation details unless there's a real reason for this. So like in this case of Webpack, okay, they had to mitigate the problem. Okay, it's fine, just implement something that works well in the engine, but in general, just try to write idiomatic code, express intent and not implementation, so that you can maintain your own code. And if you find something that is not working well, report it. Otherwise, if we don't know that there's a problem, then there's 0 chance that we can fix it. If we know that there's a problem, we can still ignore it or say, oh, I don't know. But at least we know it. Yeah, we are on Twitter. You can follow us. Make sure you get the V8JS, unless you are interested in fruit juice. This is V8. And also notice that we have more followers, so I guess more people are interested in VMs than in fruit juice. And you can also follow me, although Twitter locked me out today with their GDPR mess. But maybe one day I'll be back on Twitter. Yeah, and that's it for me. Thanks.